Hi friends, Assalamu alaikum. Welcome to Inside Winner. A winner is a dreamer who never gives up. Our channel gives you powerful mental tools to master tough subjects. If you are watching the channel first time, please subscribe the channel and click the bell button so that you will get notification of new video.
Concrete technology. The subject which deals with the fundamental principles of concrete is known as concrete technology. The practical utility of concrete technology for civil engineers is to enable them to know how to stock properly the materials required for concrete and to perform different tests for concrete. Let us discuss about the properties of concrete. The concrete in the plastic state, that is freshly mixed concrete, should have the following properties. First one, workability. Second one, segregation. Third one, bleeding. Fourth one, harsh. What is workability? The concrete should have good workability. It is defined as the ease with which it can be mixed, transported and placed in position in a homogeneous state. It depends upon the quantity of water, grading of aggregate and percentage of fine materials in the mix. Now, second term, segregation. The concrete should be free from segregation. It is defined as the breaking up of cohesion in a mass of concrete. That is, separation of coarse aggregate. It results in honeycombing, decrease in density and ultimate loss of strength of hardened concrete. Third one, bleeding. The concrete should have no bleeding. It is defined as the separation of water or water-cement mixture from the freshly mixed concrete. It causes the concrete porous and weak. Fourth one, harsh. It is the resistance offered by concrete to its surface finishing. The surface of harsh concrete remains rough and porous. The concrete in the hardened state should have the following properties. First one, strength. The hardened concrete should have high compressive strength so that it can resist the heavy loads of the structures. It should not be less than 15.5 Newton per mm square. Second one, durability. The hardened concrete must be durable to resist the effects of rain, frost action, etc. This property is mainly affected by W/C ratio. Third one, impermeability. The hardened concrete should have sufficient impermeability or water tightness so that it can resist the entry of water inside the structure. Fourth one, shrinkage. The hardened concrete should exhibit minimum shrinkage. This property is guided by water-cement ratio. Fifth one, creep. The hardened concrete should be subjected to minimum creep. It is the continuous strain which the concrete undergoes due to application of external loads. Sixth one, thermal expansion. The hardened concrete should have minimum thermal expansion so as to provide good resistance to fire. Now, classification of concrete. The concretes are classified as follows. First one, plain cement concrete, that is PCC. Second one, lime concrete. Third one, reinforced cement concrete, that is RCC. Fourth one, pre-stressed cement concrete. Fifth one, lightweight concrete. Sixth one, cellular or aerated concrete. Seventh one, sawdust concrete. Eighth one, vacuum concrete. Let us get into each terms. First one, plain cement concrete. The plain cement concrete consists of cement, sand and a coarse aggregate mixed in a suitable proportions in addition to water. The cement is used as a binding material, sand as fine aggregate and shingle, gravel, broken brick or crushed stone as coarse aggregate. The usual proportion of ingredients in plain cement concrete are Portland cement 1 part, clean sand 1.5 to 8 parts and coarse aggregate 3 to 16 parts. The plain cement concrete is strong in taking compressive stress. Second one, lime concrete. The lime concrete consists of lime, a fine aggregate and a coarse aggregate mixed in suitable proportions in addition to water. The hydraulic lime is used as a binding material, sand, surkey and cinder as fine aggregates and broken bricks, broken stones, etc. as coarse aggregate. The usual proportion of ingredients in lime concrete are lime 1 part, sand 2 to 3 parts and coarse aggregate 3 to 4 parts. The lime concrete is cheaper and has less strength than plain cement concrete. Third one, reinforced cement concrete. that is RCC. The reinforced cement concrete, also called ferroconcrete, is a cement concrete in which reinforcement is embedded. The usual proportions of ingredients in reinforced cement concrete are Portland cement 1 part, clean sand 1 to 2 parts, and coarse aggregates 2 to 4 parts. The reinforced cement concrete is equally strong for taking tensile, compressive, and shear stresses. Fourth one, pre-stressed cement concrete. The pre-stressed cement concrete is a cement concrete in which high compressive stresses are artificially induced before its actual use. This type of concrete can take up high tensile and compressive stresses without development of cracks. Fifth one, lightweight concrete. The lightweight concrete is prepared by using coke grease, cinder, or slag as aggregate in the cement concrete. This type of concrete possesses high insulating property. It is used in making precast structural units for partition and wall lining purposes. Sixth one, cellular or aerated concrete. The cellular or aerated concrete is prepared by mixing aluminum in the cement concrete. It is light in weight and spongy in structure. It is used for roof slab and precast units in partitions, etc. for heat and sound insulation. Seventh one, sawdust concrete. The sawdust concrete is prepared by mixing Portland cement with sawdust in specified proportions in the concrete. It is used as heat and sound insulating material. The last one, vacuum concrete. The vacuum concrete is the cement concrete from which endrained air and excess water are removed with a vacuum pump after placing it in position. The removal of excess air after placing concrete helps in increasing the strength of concrete by 15 to 20%. It is used for all reinforced concrete works. Functions of ingredients of cement. The functions of various ingredients of an ordinary Portland cement as mentioned above are as follows. First one, lime. Lime makes the cement sound and strong. The lime in excess quantity makes the cement unsound and causes the cement to expand and disintegrate. Second one, silica. Silica provides strength to the cement due to the formation of dicalcium and tricalcium silicates. The silica in excess quantity causes the cement to set slowly. Third one, alumina. Alumina provides quick setting property to the cement and lowers the clinkering temperature. Fourth one, iron oxide. It provides color, hardness, and strength to the cement. It also helps the fusion of raw materials during the manufacture of cement. Fifth one, magnesium oxide. Magnesium oxide provides hardness and color to the cement when present in small quantity. The magnesium oxide in excess quantity makes the cement unsound. Sulfur trioxide. It makes the cement sound when present in very small quantity. The sulfur trioxide in excess quantity makes the cement unsound. Alkalis. This should be present in small quantities. The alkalis in excess quantity will cause efflorescence. Composition of cement clinker. The cement clinkers, which are formed when calcareous and argillaceous raw materials are mixed and burned in rotary kilns, consists of following major compounds. First one, tricalcium silicate. Cement contains 40% of tricalcium silicates. The presence of tricalcium silicate in cement hydrates more rapidly. It generates more heat of hydration. It develops high early strength and possesses less resistance to sulfate attack. Second one, dicalcium silicate. Cement contains almost 32% of dicalcium silicate. The presence of dicalcium silicate in cement hydrates slowly. It generates less heat of hydration. It hardens more slowly and offers more resistance to sulfate attack. It provides good and ultimate strength to the cement. Third one, tricalcium aluminate. Cement contains almost 10.5% of tricalcium aluminate. The presence of tricalcium aluminate causes initial setting of cement. It reacts fast with water and generates large amount of heat of hydration. It is the first compound which reacts with water when mixed with cement. Fourth one, tetracalcium aluminoferrite. Cement contains almost 9% of tetracalcium aluminoferrite. The presence of tetracalcium aluminoferrite in cement has poor cementing value. It reacts slowly with water and generates small amount of heat of hydration. And the special points to be noted here that The high percentage of tricalcium silicate and low percentage of dicalcium silicate in cement results in rapid hardening, high early strength, high heat of generation, and less resistance to chemical attack. Also, the low percentage of tricalcium silicate and high percentage of dicalcium silicate in cement results in slow hardening, much more ultimate strength, less heat of generation, and greater resistance to chemical attack. Now let us study about the setting and hardening of cement. The chemical reaction between cement and water is called hydration of cement, or simply cement hydration. The phenomenon by virtue of which the plastic cement changes into a solid mass is known as setting of cement. The phenomenon by virtue of which the cement paste set and develops strength is known as hardening of cement. The rate of setting and hardening of cement, the rate of evolution of heat, and resistance to sulfate attack are affected by the proportions of different cement compounds. The sum of percentage of tricalcium silicate and dicalcium silicate for Portland cement varies from 70 to 80%. The tricalcium silicate hydrates more rapidly than dicalcium silicate and develops strength in cement for the first 7 days. The tricalcium aluminate and tetracalcium aluminophoride compounds are responsible for the initial setting of cement. Now let us discuss about the types of cements. The various types of cements available in the market are as follows. First one, ordinary Portland cement. Second one, rapid hardening Portland cement. Third one, low heat Portland cement. Fourth one, sulfate resisting Portland cement. Fifth one, high alumina cement. Sixth one, blast furnace slag cement. Seventh one, colored cement. Eighth one, pozzolano cement. Now let us check each type of cement separately. First one, ordinary Portland cement, that is OPC. Actually, this is the common type of cement in use. It has adequate resistance to dry shrinkage and cracking, but has less resistance to chemical attack. It should not be used for construction work exposed to sulfates in the soil. Second one, rapid hardening Portland cement. It is also known as high early strength cement. It is lighter than ordinary Portland cement. Since the curing period for the cement is short, therefore it is economical. It is used where high early strength is desired for constructing road pavements, for cold weather concreting, and where formwork is to be removed as early as possible. It should not be used for massive concrete structures. Third one, low heat Portland cement. It contains a low percentage of tricalcium silicate, which hydrates quickly, and a higher percentage of dicalcium silicate, which hydrates slowly. It contains less lime than ordinary Portland cement. It possesses less compressive strength. This cement is widely used in retaining walls. It should not be used for thin concrete structures. Fourth one, sulfate resisting Portland cement. In this cement, the percentage of tricalcium aluminate is kept below 5% and it results in the increase in resisting power against sulfates. It is used for structures which are likely to be damaged by severe alkaline conditions such as canal lining, culverts, etc. Fifth one, high alumina cement. It contains about 35% of alumina. It sets quickly and attains higher ultimate strength in a short period. It is used for a structure subjected to the action of seawater, chemical plants and furnaces. Sixth one, blast furnace slag cement. It is made by intergrinding of ordinary Portland cement clinker and granulated blast furnace slag. It is cheaper than OPC. It develops low heat of hydration and has less early strength. This cement is frequently used in dams, bridge abutments and retaining walls. Seventh one, colored cement. Colored cement is prepared by adding 5 to 15% of a suitable coloring pigment before the cement is finally ground. The commercial term used for a colored cement is colocrete. It is widely used for finishing of floors, external surfaces, etc. Pozzolano cement. What is pozzolano cement? Actually, pozzolano cement is made by intergrinding of ordinary Portland cement clinker and pozzolana. Pozzolana is essentially a siliceous material containing clay up to 80%. In the manufacture of pozzolano cement, about 30% of pozzolano material is added to the OPC clinkers. It is widely used for hydraulic structures such as dams, wires, etc. Testing of Portland cement. The following important tests are carried out for ordinary Portland cement. First one, fineness test. Second one, consistency test. Third one, soundness test. Fourth one, tensile strength test. Fifth one, compressive strength test. Now, what is fineness test? This test is carried to check the proper grinding of cement. It may be noted that the finer cement has quicker action with water and gain early strength. The fineness of cement is tested either by sieve method or air permeability method. In the sieve method, the fineness of cement is measured in terms of percentage weight retained on IS sieve number 9, that is 90 micron IS sieve. According to Indian standards, that is IS 269, 1967 and 1975, the percentage of residue left after sieving a good Portland cement through IS sieve number 9 should not exceed 10%. In air permeability method, the fineness of cement is measured in terms of surface area in centimeters square per gram of cement. A good Portland cement should not have specific surface less than 2250 centimeters square per gram of cement. Second one, consistency test. This test is conducted to determine the percentage of water required for preparing cement paste of standard consistency for other tests. For example, setting time, soundness and compressive strength tests. This test is performed with the help of Vicat's apparatus, which consists of a plunger having 10 mm diameter and 40 to 50 mm length. The Vicat's apparatus determines the initial and final setting time and normal consistency of cement. Special points to be noted here is that in order to make a cement paste of normal consistency, the percentage of water varies from 25 to 35%. In order to perform the initial setting time test, the water is added to the cement at the rate of 0.85 P by weight of cement, where P is the percentage of water required for normal consistency paste. In order to perform the soundness test, the cement paste is prepared by adding water to the cement at the rate of 0.72 P by weight of cement, where P is the percentage of water required for normal consistency paste. In order to perform the compressive test, the cement paste is prepared by adding water at the rate of P plus 3% of water, where P is the percentage of water required for normal consistency paste. The initial setting time of ordinary and rapid hardening cement should not be less than 30 minutes. The final setting time of ordinary and rapid hardening cement should not be less than 10 hours. Third one, soundness test. This test is carried out to detect the presence of uncombined lime and magnesia in cement, which causes the expansion of cement. The soundness of cement is tested with Le apparatus. According to Indian standard specifications, the expansion should not exceed 10 mm for any type of Portland cement. Fourth one, tensile strength test. This test is carried out on standard briquettes made of good Portland cement and standard sand mortar in the ratio of 1:3 to determine the tensile strength of cement. The average tensile strength after 3 and 7 days of curing should not be less than 2 Newton per mm square and 2.5 Newton per mm square respectively. Fifth one, compressive strength test. This test is carried out on standard cubes made of good Portland cement and standard sand mortar in the ratio of 1:3 to determine the compressive strength of cement. The size of cube mold should be 70.6 mm. The cubes should be kept at a temperature of 27 degrees Celsius plus or minus 2 degrees Celsius in an atmosphere of at least 90% relative humidity for 24 hours. According to Indian standard specifications, the average compressive strength for 3 cubes should not be less than 11.5 Newton per mm square and 17.5 Newton per mm square after 3 and 7 days of curing respectively. Note, during field test, the cement is said to be pure and of good quality when the color of cement is uniformly greenish gray. A handful of cement thrown into a bucket of water floats. Hand is thrusted into a bag of cement, it feels cool, and rubbing between fingers, it feels smooth. Repeatedly asked multiple choice questions from concrete technology. First question, the practical utility of concrete technology for civil engineers is to: option A, enable them to know how to stock properly the materials required for concrete. Option B, enable them to perform different tests concerning concrete. Option C, make them conversant with the fundamental principles of concrete. And option D, all of the above. So, here the answer is Option D, all of the above. The practical utility of concrete technology is to enable them to know how to stock properly, to enable them to perform different tests concerning concrete, and to make them conversant with the fundamental principles of concrete. All are correct. Option D is the answer. Second question. The strength and durability of concrete depends upon option A, size of aggregates, option B, grading of aggregates, option C, moisture contents of aggregates, option D, all of these. And the answer is option D, all of these. The strength and durability of concrete depends upon size of aggregates, grading of aggregates, and moisture contents of aggregates. Option D is the answer. Third question. The breaking up of cohesion in a mass of concrete is called option A, workability, option B, bleeding, option C, segregation, and option D, creep. The breaking up of cohesion in a mass of concrete is called segregation. Yes, option C is the answer. Fourth one, the workability of concrete is defined as the option A, ease with which it can be mixed, transported, and placed in position in a homogeneous state. Option B, breaking up of cohesion in a mass of concrete. Option C, separation of water or water cement mixture from the freshly mixed concrete. Option D, none of the above. And the answer is option A, ease with which it can be mixed, transported, and placed in position in a homogeneous state. Fifth question, the continuous strain which the concrete undergoes due to the application of external loads is called option A, workability, option B, bleeding, option C, segregation, option D, creep. And the answer is option D, creep. Sixth question, segregation in concrete results in option A, honeycombing, option B, porous layers, option C, surface scaling, option D, all of these. And the answer is all of these. Segregation in concrete results in honeycombing, porous layers, and surface scaling. All are correct. Seventh question. Harshness in concrete is due to the excess of option A, water, option B, finer particles, option C, middle-sized particle, and option D, coarser particles. And the answer is option C, middle-sized particle. Harshness in concrete is due to the excess of middle-sized particle. Eighth question. In lime concrete, lime is used as option A, coarse aggregate, option B, fine aggregate, option C, binding material, and option D, admixture. In lime concrete, lime is used as a binding material. Option C is the answer. 10th question. The type of lime used in lime concrete is option A, fat lime, option B, poor lime, option C, slaked lime, option D, hydraulic lime. The type of lime used in lime concrete is hydraulic lime. Option D is the answer. 11th question. The usual proportion of ingredients in plain cement concrete is option A, Portland cement 1 part, plain sand 1.5 to 8 parts, and coarse aggregate 3 to 16 parts. Option B, Portland cement 1 part, plain sand 3 to 16 parts, and coarse aggregate 1.5 to 8 parts. Option C, Portland cement 1 part, plain sand, and coarse aggregate 1.5 to 8 parts. Option D, any one of the above. And the answer is Portland cement 1 part, clean sand 1.5 to 8 parts, and coarse aggregate 3 to 16 parts. Option A is the answer. Next question. Ferro-concrete is another name given to option A, plain cement concrete, option B, reinforced cement concrete, option C, pre-stressed cement concrete, and option D, none of these. And the answer is option B, reinforced cement concrete. Ferro-concrete is another name of RCC. 13th question. Reinforced cement concrete is equally strong in taking option A, tensile and compressive stresses, option B, compressive and shear stresses, option C, tensile, compressive and shear stresses, option D, tensile and shear stresses. And the answer is option C, tensile, compressive and shear stresses. RCC is equally strong in taking tensile, compressive and shear stresses. 14th question. Plain cement concrete is strong in taking option A, tensile stress, option B, compressive stress, option C, shear stress and option D, all of these. And the answer is option B, compressive stress. Plain cement concrete is strong in taking compressive stress. And the last question. The cement concrete in which high compressive stresses are artificially induced before its actual use is called option A, plain cement concrete, option B, reinforced cement concrete, option C, pre-stressed cement concrete and option D, lime concrete. And the answer is option C, pre-stressed cement concrete. The cement concrete in which high compressive stresses are artificially induced before its actual use is called pre-stressed cement concrete. If you felt the video useful and informative, please press the like button, share the video and subscribe the channel. If you want videos of special topics, please write below in the comment box and give me your valuable suggestion. Watch all other uploaded videos to ensure top rank in all the competitive exams.